Hey guys, in this fourth part of the Harnessing AI to Become a DevOps Pro series, I will learn about orchestration. Some known tools for this is Kubernetes, Docker Swarm and OpenShift. I think I will be focusing on Kubernetes for this article. As far as I know, this is the most popular one and the only one I have actually heard about of these three. So let's just begin by going to my teacher and ask her what orchestration actually is. Can you briefly describe what orchestration is? Orchestration is the context of IT and DevOps refers to an automated arrangement, coordination and management of complex computer system, middleware and services. It involves the integration of various processes and tasks, for deployment, scaling, etc. So it seems like it's sort of tools or similar you use for example, Docker to make it easier to scale and deploy. Popular orchestration tools include Kubernetes, for example, and Apache Airflow. I feel that I know what orchestration is and what it's used for. So I will just make Clio come up with some sort of hands-on experience task for me. Can you come up with a hands-on exercise so I can learn the basics of Kubernetes? Okay, so here's a simple guide. Perfect. That should get us started. Install Minikube and kubectl or kubectl, I think it's pronounced. I already have this, but I think there should be a simple guide here if you want to follow it. I don't have this already. Yeah, you just copy these two here and you should be ready to go. Okay, and same goes with installing kubectl or kubectl. So the exercise steps: start Minikube, open your terminal, start Minikube with the following command: Minikube start. I know that I sometimes copy and just paste the commands, but writing them myself makes them stick better in my fingers, so I should actually be better at doing that. So restarting Kubernetes, verifying. So now done. Kubectl is now configured to use Minikube cluster and default namespace by default. So then looks like I now should have a local Kubernetes cluster. Use kubectl to create a deployment. This will deploy simple. So this will start some sort of service with nginx. kubectl create deployment nginx. Image is nginx. Okay, the deployment is created. Not sure what that actually means. Expose the nginx deployment to make it accessible outside the cluster. So kubectl expose deployment nginx --type equals node port --port equals 80. Okay, there was some sort of typo probably, not post port. So now that is exposed, and then access the application Minikube service nginx --url. Okay, so now we can see the URL that this nginx has started in. Copy and paste. Welcome to nginx. Cool. So now nginx is running somewhere on my Docker or Kubernetes thing. Next thing we can do is to scale the deployment. Now we just need to stop kubectl scale deployment nginx --replicas equals 3. So this is scaled. I I will read this after and see what we have actually done. kubectl get pods. Yeah, you can see here it looks like there are 3 instances of Nginx running here. Deleting the Nginx deployment and service. Okay, I can just copy these 2, paste, and minikube stop. Okay, so now we've created the deployment with Nginx, scaled it, stopped it, and cleaned up everything. Can you describe a little bit better what we did? What is actually a deployment? For example, I'm not sure exactly what this is. So what we did, we started Minikube, which is a tool that allows us to run Kubernetes cluster locally. Next, we created a deployment. And a deployment in Kubernetes is a resource object that provides declarative updates to applications. It manages the creation and scaling of a set of pods, the smallest deployable units in Kubernetes, and ensures that the desired number of pods are running at a given time. In the exercise, we did this. Okay, and then we exposed this. Yes, I understand what that did. Then we got the URL for what was running. Then we scale it and clean up. That's okay. I understand. Then, how is Kubernetes connected to Docker? Okay, so they are closely connected because both play an essential role in the containerization ecosystem. Docker is a platform that allows you to package applications, but Kubernetes is a container orchestration platform that automates. Okay, because earlier I thought that, for example, Kubernetes was some sort of layer on top of Docker, and that the Kubernetes was helping Kubernetes to, Docker to scale and similar. But Kubernetes uses Docker images to create containers. When you deploy an application in Kubernetes, you specify the Docker image to use, and Kubernetes pushes it. Okay, so they are sort of connected. Can we replicate the Flask app but with Kubernetes instead? Okay, that was a little bit longer than I expected, but yes, we still have this. Let's just go into this Flask Docker app from the previous part where I have this, have the Docker file and the Docker compose and the virtual environment if I need that. Create a file called this one. No, we can just install, if I say cat Docker file, you can see here that we are just installing Flask this way. So instead of using a requirements.txt, we just install it using run pip install Flask, which will also install all of its dependencies. Then we need to build and push the Docker image. Okay, hopefully I can skip this because I don't have a container registry, but let's try to do this step at least. Like that. And then we need to create a new file called deployment.yaml. Why not YML? Okay. New file deployment.yaml. Paste everything and fix the indentation. It looks like we actually need to do this, so I think I will skip that part, but we can still do all of the stuff so far. Then we need to apply the deployment. That will then crash since I have not done this. Expose the deployment with the service there. Now we started there, and when this service is started, we can access this just like we did earlier. And then in the browser, it should show this page, the Hello World application. This one, Hello Docker. Okay, so yeah, I don't have an account to a container registry. I guess I can just ask simply how I did it, but yeah, it's not something I need to do just to test this. So far we have learned about a little bit about Kubernetes, how it works, how it is connected to Docker and similar. And we also learned about scaling and similar. So far everything has been easy to follow, and yeah, I don't think I need any follow-up questions for this. Yeah, maybe we can ask her one thing. I went through the basics now, but can you explain what a cluster is? So, okay, that's down there. In the context of Kubernetes, a cluster is a set of nodes, so sort of machines that run containerized applications managed by Kubernetes. The Kubernetes cluster is a collection of nodes that work together to run. It provides a platform for automating deployment, scaling, and operations around the application. Okay, so you typically have two main components: the control plane, which probably is like the one that orchestrates all of the stuff, like the API server, controller manager, scheduler, and then it controls all of the nodes, which are worker machines in a cluster. So a cluster works by having pods and nodes. Applications are deployed in containers, which are encapsulated in pods. Pods are scheduled to run on nodes, and each of the nodes can run multiple pods. Kubernetes automatically distributes the loads across nodes and can scale the application up or down on demand. Okay, there's also a few good benefits like resource efficiency, scalability, high availability, and automation. Okay, so I think I understand most of this now. I think that I should spend some time learning more about this and trying to do more hands-on, for example in some sort of real life exercise. Are there anything else I should know when it comes to Kubernetes? Maybe there are some other important concepts that I should know more about. Namespaces, config maps, and secrets. Okay, this is something that we often use. Maybe we should try to get hands-on experience with that one. Best practices. This is something we will come back to later, as well as this. This is something we already have done a little bit more about, but maybe we should do one more video where we connect CI and CD with Kubernetes and what we have learned today. But let's take this one and say, can you come up with a simple hands-on exercise for learning config maps and secrets? Let's try to do one more for this video. Just need to see that I actually can do everything here. Yeah, I think so. Let's just keep using this Flask Docker app that we used earlier. So we just need to configure this, import OS, so we actually can read the environment variables. Import OS, and then we can take this one, paste it there, take the secret value, and instead of just returning hello world, we are returning both of these two values. Now we can save this. Skip this because we already have the Docker file and Docker compose, but we can build, just search here, build Flask app and the folder we are in now, and then we need to do this, create a config map. Let's copy this, go back and see if we can create a new file, config map.yaml, I think that's correct, config map.yaml, and paste this. fixed indentation, and then we have the config value there. Then we need to apply this. I need to write this kubectl apply -f config map. Okay, there's something wrong. Refused. Why is that so? Everything seems to be correct there. Maybe it's something with this one. Let's just delete this. Try one more time. No, it's still there. Error validating. Okay, I will just do the rest here so that we can test this. So then I will ask for that error afterwards. Then we create a new one called secret.yaml. Secret.yaml paste and fix indentation. And then let's try to apply this one. That did not work either. Seems something wrong with localhost 8080 connection refused. Then we need to create a deployment. So that's a new one of the one we just had. Deployment.yaml paste fix indentation and save. I guess I can't do that either. So let's copy this, create a new service.yaml, paste, fix indentation and save. And since I can't do that either, I can now copy this here, take the first one, config map, see what she says for this one. The error message, your container suggests the kubectl is unable to connect to Kubernetes API server on your local, blah blah blah. Okay, it's probably because I stopped Minikube previously. Okay, so let's start this again. Because I can't remember that she said so here, maybe I need to have this here, but there was nothing information about that I had need to have this running, but I maybe should have remembered that from previously. Okay, so let's apply the config map. That was good, perfect. Then we can scroll up and do the same thing for the secret YAML, and then for the deployment, and for the service. Okay, everything is good. Then we can try to start this. No, no running pod for service. Maybe it's because I tried to use my previously, this name. I started mine as a Flask app. I guess if I go in here, I will find my Flask Docker app. Let's try to build it one more time with this name instead. And then we start Minikube like that. Nope, still not working. Maybe it's something with this Minikube. If you restart it, stop and start it again, maybe that fixes it. Then we can run this again to see. Nope, not working. Okay, let's copy this here. So nice to have a teacher to ask for this. Okay, check pod status. So copy this, paste. So we have a name there, but it looks a little bit longer than this one. Let's copy and paste and see if that fixes it. No, that did not work. Kubectl describe to get more details. Kubectl describe pod and then this name. Yeah, it looks like this is the same thing as previously because I don't have this account. Okay, so if you have an account where you pushed the code like we talked about previously in this video, it will probably work with you. So the problem is that I don't have that account and can't download this image. So even though this was fairly easy to follow along, I just messed up because I don't have the account on the, not the repository site, but the container page or whatever she called it. Having secrets and maps like this that we try to learn now is very important to know about because it's something that we often do in the DevOps world or the developer world. So I think it's enough Kubernetes so far today. I will definitely come back to this later in the series and use it in a combination with other things we are learning. In this part we learned the basics of Kubernetes and also got some hands-on experience with the cluster and also secrets/config maps. In the next part of this series we are going to learn about infrastructure as code or IAC.